Okay, let's do it. This is, let's see, Physics 142, Fall 2020, Quiz 3. I'm under the impression that everybody's already taken this quiz, which is why I'm helping out by explaining my approach, how I would approach this, so that you can take away some tips and improve your own problem-solving skills. Here we go. Let's do the first one. So a person walks or moves 665 meters. So I'll say that's east for me. And that is 665 meters. 65 meters. Okay. And then the person turns and walks 740 meters at an angle of north of east. Okay, so you have to really look what's the anchor. The anchor is east. So from east, they walk, this would be kind of like east, right? And they walk 30 degrees north of it, you know, that's how much they turn north. They turn 30 degrees north of east, right? So basically they go something like this and 740 meters. Okay, and we want to know their final displacement, which is like saying, well, you know, from point A to B, how much did they move, did that person move? So that would be something like that, because our vectors are already connected tip to tail. They're already connected tip to tail. So it's this vector, right? This is the resultant vector. So probably everybody got this. Now we have a simple, how to say this, magnitude, right? So let's try doing it this way. So I'll call it the first vector and the second vector. And I'll call it X and Y, just because it's easier, right? So what they're calling east is actually just positive X for me, right? It's in the coordinate system, that's just plus X. And that's what we're calling east here. So the sign helps me, it tells me I'm going east. So I'm going to say that they were plus 665 this way, meters, right? And they didn't move anything in the Y direction. So first, that's the first vector. Now the second vector, I don't know the X and Y components. I have to calculate them. So you can use SOHCAHTOA. SOHCAHTOA, where this mnemonic basically boils down to sine of, that's where the S comes in. Sine of the angle is equal to opposite. That's where the O comes in, over hypotenuse. So this is kind of a trend. It goes with cosine of an angle is equal to adjacent. Adjacent means something right next to you, touching. And then hypotenuse goes under. I'm assuming everybody's familiar, but just in case you're not, then there it is. Tangent of the sine is equal to opposite. It's just a mnemonic, really, over adjacent. Adjacent. Okay, so with that crazy explanation with a lot of arrows, hopefully you kind of get it. Let me erase that. There's an easier way. I mean, if you're working with a simple problem where something is not sliding down the incline, the easy way to remember, it's about contribution, right? This vector is going off in a weird direction and you want to simplify it in the X and the Y. Usually, if you're working with a simple coordinate system like we are here, the contributions in the X direction of a unit circle work out to be cosine. So, if this is a resultant vector, if that's your hypotenuse, that cosine of the angle will be the X. Anyway, let me not give my own shortcuts, stick with what we know. So here we are, right? So we know the angle is 30 degrees. And we know in this case, we happen to know the hypotenuse. The hypotenuse is 740. So what we want to do is we want to work back to sine, right, is equal to SOHCAHTOA opposite over hypotenuse. Now what's the opposite? Let's take a look. Right, if that's 740 and this is 30 degrees, which side is the hypotenuse, right? I'm sorry, which side is the opposite? This side is the opposite. So that means the Y vector is the opposite. And the vector touching the adjacent vector, xy, is just x. X is touching the 30-degree angle, right? So sine So to hypotenuse is 740. So sine of 30 degrees. So that's how we can solve this equation to get, oh, so the opposite is just, 740 times sine of 30 degrees. And that opposite we just said was the y system, right? Similarly, we can do 740. Well, if this is sine, then the other thing is cosine, right? So the x adjacent, which is coming from cosine of 30 degrees, is equal to adjacent over hypotenuse, right? Cosine SOHCAH to a CAH, SOHCAH to a, hopefully that makes sense. And, so you take the hypotenuse to the other side and you end up with that equation. So we've got, I'm not going to solve these, but you've got y is 740 times sine of 30 degrees. And you've got x is 740 times cosine of 30 degrees, right? And you can solve that. And when you solve that for the resulting vector, you will get, an answer right here and here. So you will get a value, I'll just call it the Rx value and the Ry value. And then you'll wonder, well, what's the real vector, right? So you'll just say, oh, Rx square plus Ry square is equal to, Pythagoras theorem. I don't know if anybody remembers that. Probably everybody remembers that. A square plus B square equals C square. So that way you can find the real vector, which is then you just square root the thing and this goes away. And then if you had to find the angle, you would do TOA. So you could just take tangent of the angle is opposite over hypotenuse. And you can take a look, if you're trying to find this angle, because that's your resultant vector, the opposite would be the y and the adjacent would be the x. So the opposite would be the ry and the adjacent would be rx. Whatever values you found, you just plug them in and you then do, the inverse tangent actually, because you want to get rid of that and the angle is all along. And now you've got the angle. So I'm not going to solve the math, but that's basically all you should have to do. And then you can find the person's final displacement. And this is not even asking about the angle. It just wants the final displacement. Actually, it is. Displacement is, yeah, it's a vector. Displacement is a vector here because we can't just say that they're X meters away. We have to say they're, you know what? I'm being dumb. Oh gosh, what's happening in my brain? I feel like you don't have to give the angle, but no, yeah, you do have to give, the angle. It's a displacement. Yes, displacement is a vector. Okay, I sure hope I don't get my circuits crossed again. So that's it for now. I'll record the next problem in a separate video.